Titanium is 40% heavier than carbon and less stiff than steel. Yet, for a materials engineer, this is the only perfect element in the periodic table for a bicycle. Let's look at the density numbers. Titanium sits at 4.5 grams per cubic centimeter. This is the Goldilocks zone, 56% the weight of steel, but significantly denser than aluminum. This allows engineers to use thin-walled, large-diameter tubes to achieve stiffness without the catastrophic failure modes of composites. But here is what marketing glosses over: Young's modulus. Titanium is actually half as stiff as steel. This 110 GPa modulus is why titanium has that legendary springy ride quality. It naturally dampens high-frequency road vibration while maintaining better power transfer efficiency than a fatigue-softened aluminum frame. The catch? It hates oxygen. Molten titanium absorbs oxygen instantly, creating a brittle structure that cracks under load. It requires welding in an argon-purged environment, which drives the manufacturing cost up by 300% compared to steel. Most brands simply can't justify this expense for a mass-produced bike. However, this chart explains why you should pay that premium. This is the SN fatigue curve. Aluminum has no fatigue limit. It will eventually fail with enough cycles. Titanium, like steel, flattens out. Unless you crash it, a titanium frame has an effectively infinite structural lifespan. Modern 3D printing is now solving the aerodynamics problem, allowing for shapes previously impossible with round tubes. If you are racing the Tour de France, buy carbon. If you want a high-performance machine that your grandchildren can inherit, titanium is the only logical choice. Titanium, the only bike you buy once and ride forever.